The question being posed is, how much milk does the farm produce every day? The rate at which the milk is produced can be graphed by the function negative 0.072x times x minus 11 times x minus 12 times x minus 18. When this function is graphed, it looks like this. The farmer begins collecting milk at midnight and continues until 11 hours later, at which 11 until 12 they take a break, and then begins collecting milk again from 12 until 6 o'clock in the afternoon. When taking the integral from 0 to 18 of the function, we get 1,550 gallons. This is how many gallons is produced throughout the entire day. Each day, the farmer collected 1,514 gallons of milk, not the total amount of milk that he needs. The total minus the amount that is collected is 36 gallons. 36 gallons divided by 18 hours shows that 2 gallons per hour was stolen. Will he clear the gap? Our robber is trying to escape from the cops, and he has to jump off a hay bale that is approximately 3 feet tall. The gap that he is trying to clear is 4 feet. In order to figure out whether or not he will make it across the gap, we're going to use a somewhat physics equation. We know that his initial acceleration, or his total acceleration due to gravity, will be negative 32 feet per second squared, and his initial velocity that he's jumping at is 16 feet per second. Using the equation v2 squared equals 2ad plus v1 squared, we can solve to see how far the robber will make it and if he will clear the gap. Knowing that the final velocity is going to be 0 feet per second and his initial velocity is 16 feet per second, and also using a as negative 32, we solve the equation for 0 equals negative 64d plus 256. When solved completely, d equals 4, which means that the robber will just barely clear the 4-foot gap. cops will catch the robber, we need to know the velocity function of both the robber and the cops. The destination of the robber is the pond, which is 1 kilometer away. In meters per second, the robber is going at 8 sine 0.1x plus 15, and the cops are traveling at a constant velocity of 14 meters per second. To determine whether or not the cops will catch the robber, we need to know what the average speed of both of them are. The integral over the interval will give us the average speed. The integral from 0 to 67, which is the amount of time it takes the robber to get to the pond of f of x, the robber's velocity, is 1000 over 67, which ends up being 14.925 meters per second. The average velocity of the cops is the integral from 0 to 67 of g of x, which is 938 over 67, which gives the cops an average speed of 14 meters per second. Knowing that the average speed of the robber is faster than the average speed of the cops, we can tell that the cops will not catch the robber before he gets to the pond, leaving the robber to get away. Oh no!